See Lindelof videos sketching a rational function. So let's try to take a look at the graph. Y is equal to the opposite of 3 over x plus 2. So the first thing I did was this. Just for today, I just thought I'd look at it this way. Say, okay, this is the graph of that. What you have here in black, this piece and this piece are that graph. This piece right here is the vertical asymptote that separates those two parts. So I guess the question goes to, why does it look the way it looks? So to go back to it just for a second, as soon as we look at this and we see that it's a rational function, we know it's rational because it has a variable in the denominator. Has this variable here in the denominator. So the first thing I'm going to do is I'm going to look at this, and I'm going to look, and I am going to look right here. I'm going to look at x plus 2. I'm looking at this part right here in the bottom of it, saying, when does that thing equal 0? So when does x plus 2 equal 0? Well, it equals 0 when x is negative 2. Why do I care about that? Because if I put negative 2 in for x, I'd have negative 2 plus 2 is 0. 3 over 0, undefined. Makes no sense, right? 0 over 3 would make sense. That would be worth 0, but 3 over 0 makes no sense at all. So we have here, as our domain issue, we said, well, x can't equal negative 2. From there, I'm just going to do this. I'm going to say, I'm going to start my Cartesian plane here. This is the x-axis. This is the y-axis. And I'm going to draw this line in right here. This line right here. And if you don't mind, I'm going to call this line x equals negative 2. Because we know now that x is not allowed to equal negative 2, right? So it can equal every other value except for negative 2, but not negative 2. So the question is, what happens? And we know with rational functions that what they do is they run up towards the wall, and then they turn one way or the other. The question here is, which way are they going to turn? And Damien, a good way to think about that might be to say, well, what happens way out here? Let this be negative infinity, and let this be positive infinity. So I guess the first thing I would do is say, well, what happens out here? So what I did was I went to my calculator. I put that function in. I saved it in the calculator. I just saved it. And then what I did was I took f of infinity and said 0. And then when I took f of negative infinity, it also said 0, which is kind of good but not good because it didn't tell me if it was over 0 but really close to 0, or under 0 really close to 0. So I decided to do it a different way. So I took f of negative 10,000, and I got back this crappy answer right here. So I asked the calculator to give it to me in decimals so I could understand it better, I guess. So I asked it again, and it said, well, f of negative 10,000 is 0.0003. Tenths, hundredths, thousandths, 10,000ths. So it's 3 10,000ths about. Well, tell me something about that. What is that number close to? It's close to 0, but what? But over 0 or under 0? Over 0. So it took me here. I'm like, oh, you know what's really weird? When way out here, it's over 0 because I know that this function will not cross this. How do I know that? Because this thing here is x gets huge. This thing goes to 0, and I want to know if it's on top or under 0. So it's over 0 here. So then it's going to approach this way, isn't it? Then what's going to happen when it gets to the wall? Is it going to turn down or turn up is the question. How do we figure that out? Exactly. We approach. So we're going to approach the forbidden number. We're going to approach x equals negative 2 from values less than negative 2. That's what this second negative sign means, less than negative 2. So I'm going to do that with my calculator just to get an idea of what it's going to do. So here, I'm going to put in f. Give me a number close to negative 2, but less than negative 2. Too far away, right? When we do approaches in math, we want to approach from values very close. So yeah, maybe negative 2.1, so negative 2.1. I'm starting somewhere near that forbidden number, but right? And it comes back as 30. So I'm going to approach one more time just to see if there's a trend here. So I'm going a number to the left of negative 2, but even closer would be, yes, so f of negative 2.01. Can we agree that 2.01 is closer to negative 2 than negative 2.1? See what happens. So we can say with some certainty now that this function does this, doesn't it? From this side, as it gets really, really close to x is negative 2 from the left-hand side, it goes up, doesn't it? What do you think it's going to do from this side? First thing I have to do is find some in behavior. So I went back to my calculator, asked the calculator. I said, what's f of 10,000? And it gave me negative 0.0003. About how much is 0.0003 worth? It's about worth 0, isn't it? But it's negative. So is it over 0, close to 0, or under 0, close to 0? Under 0, but close to 0. So way over here. Very close to 0, but less than 0. And now we make our approach, right? Because we know this thing is going to do this. We know it's going to head this way. The question is, when it gets really close to this wall, what will it do? You can't assume. You can't just say, well, the first one went up, so the other one has to go down. That's not always true. Sometimes they both go up. Sometimes they both go up. So how do I figure that out? Same thing we did last time. I approach negative 2 from values what? Greater than negative 2. Like what? F of negative 1.9. Now I'm on the other side of negative 2, aren't I? Hit enter. Negative 30. That's kind of weird, isn't it? What's a number even closer to negative 2 but on the right-hand side? Sure, negative 1.99. So f of negative 1.99. Guess what it's going to be? Negative 300. So that provides proof of this, doesn't it? That just what you thought was going to happen. It's going to come up to the wall. As it gets to the wall, it's going to bend down. So as we get really close to negative 2 from the right-hand side, the function dives down really hard, doesn't it? As we get really close to negative 2 from the left-hand side, moving right, goes to positive infinity. How's that? Doable? Got to have a plan, though.